in the last video, we saw what is called Bhuta Sankhya system, and Bhuta and Sankhya, use some Bhuta to represent a Sankhya. Now we will see another interesting system called Kaṭapayādi system. It is called Kaṭapayādi, means in Sanskrit, Adi means etal, ... Ka, ta, pa, etc., etc. That's what it means. Kaṭapayādi system means ka, ta, pa, ... that system, which means it uses all these consonants and does something with that and relate it to numbers. That's the idea of this system. We will see this system in a little detail and see one or two examples also. Now, Kaṭapayādi system is actually a system to convert the numerals to words. But unlike the Bhuta Sankhya, whereas an entire word is used to represent a number, here an alphabet will be used to represent a number. So, we associate a number to one or more alphabets in a particular way rather than the full word that we did in Bhuta Sankhya. So, that is the only difference. So, it uses letters and connect it to the numbers. And once this association is established, once we know how to make this, then the number can be replaced with a corresponding alphabet, and so one can put all the alphabets together, you get a word or a shloka, whatever you need, you may actually get it. So, basically what Kaṭapayādi is doing is it is using the alphabet in the place of numbers, that, and with that one can construct words, so the assemblage of numbers become words finally. So, that is the logic. Now, so therefore, when we decipher a Kaṭapayādi system, we have to take one alphabet at a time, so that it will reveal the number expressed in that particular word by a combination of all these alphabets. So, that is how it is done, and the advantage again lies in representing large numbers using a nice word which we can very easily remember. All those advantages of Bhuta Sankhya also exist in the case of a Kaṭapayādi system. Now, we will see some of the governing rules with which Kaṭapayādi system works, and then we will take some examples to understand it. Now, the rules are as follows. Rule number 1, the vowels when standing alone indicate the number 0. So, if it is just a or e or whatever, then it actually represents a number 0. That is the first rule. In all other cases, when the alphabets are conjoined with consonants, it is merely to facilitate the pronunciation of the consonant. So, when you say ka, ka actually has ik and a. The ik is the consonant, a is the vowel, but the vowel is used more for ease of pronunciation. Beyond that, it does not play a role. So, when you say ka, you are looking at some number related to ik without that consonant, without the vowel, no? That is what it is. So, each consonant is uniquely associated with the number 0 to 9 now, and the standalone vowel also is 0, but the consonants can be any number between 0 to 9, and more than one consonant may be associated with each of the numeral. For example, one can be ka or ta, things like that. So, you can use more than one consonant to represent the number 1. In the same way, we will see a table of these numbers, we will understand it. The other rules that follows are as follows. When more than one consonant is used in conjunction, for example, you have samyuktakshara, no? They call it a samyuktakshara, then only the terminal consonant preceding a vowel is to be constructed. So, if you say yukti, I am just taking example yukti, ik, it, tha, ka, tha and e makes ti. So, we will ignore all ka, only we will take only the tha. In other words, the last consonant which is associated with the vowel alone is used, all others are ignored. So, that is another rule. A standalone consonant will be ignored, but a standalone vowel will have a value 0, as we saw already. So, these are the ground rules. Now, let us look at some specific examples. First, let us look at the table, and then we will look at the specific examples to understand the Kaṭapayādi system. So, what you see here is the table which has the Kaṭapayādi system, and for example, ka. Ka means 1, ka is 2, ga is 3 and gha is 4. So you have 1, 2, 3, 4. And then nga is 5. Cha, cha, ja, ja, nya. So 6, 7, 8, 9, 0. So if you want to represent 0, one way is to use nya. Then you have the second row, you see, you have tata da da na and tata da da na. So they represent 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Then in the third row, you have papa, baba, ma, which is 1, 2, 3, 4, 5. Then the last row 4, you have ya, ra, la, va, sa, sha, sa and ha. So which runs from 1 to 8. So now you have a good possibility of using these vowel consonants to represent the number 1 to 0. As I mentioned earlier, let us say we want to represent a number 3. So if you want to represent a number 3, this entire column can be alternatively, you can use ga, or you can use da, or you can use ba, or you can use la, any of these. Similarly, if you want to represent a number 9, then you go to this column, what you find is you can use ja or dha, any of these two can be used. So now we have a mechanism to represent numerals with letters or alphabets. Now let us look at some examples. Here is an example bhavati, right? So let me first split bhavati into individual pieces, bha, va and ti. So you take bha, so let us look at where bha is in this table. Bha is here, so the number bha represents 4 as you see here. Bha means 4. Then you have va. Va is also 4, it is in the same row as you see here. Va is also 4. And then ti. Ti is, you ignore the e and you look for tha. Tha is a number 6 as you see here. So you have a number 4, 4, 6 and that is how you get this. And as I mentioned in the Bhuta Sankhya video itself, we need to reverse it because we read from left to right. So basically the number is 644. The number 644 can be represented with a simple word bhavati. That's the idea here. Let's look at one more example. Here we have Shaktya Loke. That seems to be the word. Again, if you split it, you have Sha, then you have a Samyukta, Samyuktakshara, Ik, It, Ya and Thya. Thya is there. Then Lo and K. So there are 4 of them. Sha, as you see from here, represents 5. In Thya, we ignore all the consonants except the one before the vowel, which happens to be Ya. Ya is 1 as you see here, so therefore we take the number 1 as the second digit. Lo is La. La as you see here is 3, so the third digit is 3. And then K. K is Ka. Ka is again a number 1. So therefore the number is 5131. If you reverse it, it becomes 51315. So 1315 is represented by Shaktya Loke. That is the word that we are using as per the Kaṭapayādi system. We will look at one more example. This is a very special example, that's why I took this example. This word here is Ayur Arogya Saukyam. It's a nice word. Ayuhu is life, Arogya is health, Saukyam is feeling good and all that. So Ayur Arogya Saukyam. So we will split it. We have A, standalone vowel, which is 0 as per our rules. And then U is the second one. U is Ya. Ya is a number 1. So you have 0 followed by 1. Then Ra. Ra is number 2 as you see here. Ra is number 2, so therefore the third number is 2. And then again Ro. Ro is again Ra. Again number 2 comes for the second time. Then you have a Samyuktakshara Gya. So remove the Ga and take only Ya. Ya is again the number 1 as per Kaṭapayādi. So Arogya. Saukyam. Sau. Sau is Sa. Sa is 7 as per this table. So you have 7 here. Then you have Kya. Kya is again Samyukta Akshara. Ka and Ya. So we ignore Ka and take only Ya. That becomes 1. right, as you see here. And im is there finally. As I told you, a standalone consonant has to be ignored. So you just leave it. So the number that you have are 0, 1, 2, 2, 1, 7, 1. So reverse it. When you reverse it, you get this number 1, 7, 1, 2, 2, 1, 0. This number seems to be a large number, right? 1,712,210. The specialty of this is in the last shloka of a famous work called Narayaniyam, written by Narayana Bhattatri, in which he has given this word. This is where you see the corresponding shloka. It says Pitam Leela Vata Rauridimiha Kurutam Ayur Arogya Saukyam. That's how it ends. That Ayur Arogya Saukyam, according to some people, when translated using Kaṭapayādi, which gives the number 1712210, is actually the number of elapsed days from the beginning of Kali Yuga, and that day marks the day on which this Narayaniyam was actually offered, composed and offered, or whatever. So, such a complex number is written with a beautiful word called Ayur Arogya Saukyam. That is the idea of this Indian representation of numbers using letters and words and so on. I want to end this with a beautiful actual use of Kaṭapayādi system. What you see here is a very beautiful chakra. I mean, this is called Melakartas in Carnatic music. There are 72 ragas, and the 72 ragas are organized. It is a sort of a permutation combination. It is organized in such a way that the Shadjam, Panchamam, Daivatam, Nishadam, all these Rishabam, Gandharam, there is a certain combination in which these Saptaswaras form these ragas. But the charm of this is the 72 names of the ragas are as per Kaṭapayādi. Therefore, if you know the raga name, you can identify to which Melakarta it belongs to. So let us see some examples. Now let us take, there is one Mecha Kalyani. There is one raga called Mecha Kalyani. So if you look at this, Me is the first letter here, and if you go to the table, Ma actually belongs to 5. Then the second one is Cha, and Cha, as per the table, if you see here, Cha is actually 6. So it is 5 and 6. So if you reverse it, it becomes 65. What you will find is the 65th raga that you see here in this chart is actually Mecha Kalyani. So that's how, look at the second example, Vagadishwari. So in Vagadishwari raga, the first one is Va, and as you know, Va is actually 4. Then the second one is Ga, and Ga in this table, as you see here, is 3. So basically 4 and 3, you replace it, it becomes 34. So if you look at the 34th raga, that is called Vagadishwari. So that's how this name has come using Kaṭapayādi. Then I am taking one more called Ganamurti. This raga is called Ganamurti. So Ga, as per this table, is 3, as we have already seen, and then Na is, as per this table, is 0. So it is 3-0. Therefore, if you replace it, it becomes 0-3. In other words, 3. So the third one is called Ganamurti. So look at the charm of this. These 72 ragas, if you know, then you can identify the Melakarta or the sequential order from 1 to 72 where it is by using Kaṭapayādi. And once you know it, then you immediately know what is the Rishabha, what is the Gandhara, what is the Daivata, and what is the Nishada, what is Panchama and Madhyama. So the 7 Saptaswaras can be easily remembered. So they use the system like this. I thought I will show you this. There are plenty of such examples just to tell you the power of representing numbers either by using alphabets or by using Bhuta Sankhya, as we saw. It opens up a very imaginative ways by which we can handle very large numbers, remember them easily, and then process them the way we want. That's the charm of the Indian system of representation of numbers. I think we will stop here. As I told you, there is a third system also called Aryabhatian system. It's a little complicated, so I decided I will not introduce it here. If anybody is interested, you can always find it out what it is. So that is also there, Aryabhatian system. So we will conclude this representation of numbers here, and we will move on to the units of measurement that Indians were putting to use thousands of years before, and let us understand a little bit more of that in the next video. Thank you.